Hello viewers, tutorial 10 question 8. Find the turning points of y equals x cubed plus 6x squared minus 1 and their nature. So turning points are what we're finding, which means we need to set the derivative of the function equal to 0. So let's differentiate the function. Y dash equals x cubed differentiates to 3x squared. 6x squared differentiates to 12x, and that's it as far as the derivative is concerned, because there is no contribution from the negative 1. And we make that equal to 0 for turning points, and we need to solve that equation. It's quadratic, and there's a common factor of 3x. So if we take out that factor of 3x, then we've got 3x times x gives us 3x squared, and 3x times 4 is 12x. So either 3x equals 0 or the bracket equals 0. So therefore, if 3x equals 0, we can divide that by 3 to get x equals 0. And we can make the bracket 0, so x plus 4 equals 0 would imply that x equals negative 4. So we have our two values for x. Now we'll need to work out which of the 2 points is a maximum and which is a minimum, which it means by their nature. So in order to do that, we'll need the second derivative. So let's get that now. 3x squared, differentiate that, we get 6x, and 12x differentiates to 12. Okay, so for x equals 0, let's get the y coordinate. So y of 0 is going to be 0 to the power of 3 plus 6 times 0 squared minus 1, which is negative 1. Now let's work out the second derivative and substitute in x equals 0. So that's going to be 6 times 0 plus 12, which gives us 12. Okay, so we got a positive answer from substituting 0 into the second derivative. Positive answer tells us that it is a minimum. If that was a negative number, it would be a maximum. I'm expecting to get a maximum at x equals negative 4, and you'll see how that shows up when we get there. So the minimum was at the coordinates of x equals 0 and y was negative 1. We don't actually use the value of the second derivative itself. We're only interested in whether it's positive or negative, because that tells us whether it's minimum or maximum. But we don't use the value itself. Now for x equals negative 4, y of negative 4 is going to be negative 4 to the power of 3 plus 6 times negative 4 squared minus 1. So negative 4, cube that, we get negative 64. 4 squared, negative 4 squared is 16 times 6 is 96 minus 1. So negative 64 plus 96 is 32, minus 1 is 31. Okay, so let's substitute negative 4 into the second derivative. So we have y dash double dash of negative 4. If we substitute it into y dash, we would get 0, but we already know that that's 0, because that's how we got x equals negative 4 in the first place. So y double dash of negative 4 is, we're substituting negative 4 into the derivative, which is 6 times negative 4 plus 12, which is negative 24 plus 12, which is negative 12. Okay, so it's a cubic function. We got from the second derivative equal and opposite values, 12 and negative 12. For cubic functions, where the highest power of x is an x cubed and there's no other kind of functions like exponentials or sines, etc. involved, generally you can expect to get equal and opposite second derivatives like what we're getting here, 12 and negative 12. Negative 12 is a negative answer from the second derivative. Tells us that we have a maximum. At what were the coordinates? X was negative 4 and y we found to be 31. Okay, thanks for watching. Over and out.